Okay, so notice that pi to 3 pi over 2 is another way of saying third quadrant.
180 to 270 degrees.
So sine and cosine are both negative, tangent is positive. Okay, so when I do this, I'm going to have to, I draw the picture. Tangent is 3/5. I'm going to draw a generic angle in the third quadrant. Label it with opposite 3, adjacent 5. Okay, but these are both wrong because it's third quadrant, so put in negatives. The hypotenuse, since we're getting the hypotenuse, we add. Okay, there we go. And it says find cosine. Cosine is adjacent over hypotenuse, so there you go. Cosecant is -7/2. Notice that that puts the hypotenuse on top.
Reciprocal of sine.
Okay, cosecant is the reciprocal of sine, so instead of being opposite over hypotenuse, it is hypotenuse over opposite. So 7 opposite is -2. Always make the hypotenuse positive. And this third side, let's see, what is the adjacent? It's going to be 49 minus 4, so that's pretty easy. No, it's not. It's going to be negative. All right, so then cotangent is adjacent on top. So we're going to do negative square root of 45 over -2. And yes, you must simplify at least the square root, the negative signs. Okay, basic trig identity. The most basic trig identity, the fundamental one, is that sine squared plus cosine squared is 1. And that comes from the picture.
Python.
1 is the hypotenuse, then sine is opposite, and cosine is adjacent. So if we do one of two things, we can get the other trig functions. If I divide the picture by sine or divide the equation by sine squared, I get, let's write the equation down again. Sine squared plus cosine squared is 1. Divide everything by sine squared. And remembering that, okay, sine squared over sine squared is 1. And cosine over sine is cotangent, so cosine squared over sine squared is cotangent squared. And 1 over sine is cosecant, so this is cosecant squared. If we divide by cosine squared instead, again, writing the original basic identity down, dividing everything by cosine squared, we get sine over cosine is tangent, so we get tan squared plus 1 is secant squared. So you will have to remember these. So sine squared and cosine squared, they're sort of interchangeable. You have to be careful with cotangent and tangent because they're not interchangeable with cosecant and secant. Cotangent squared is always smaller than cosecant squared. So be careful with that. Complementary statements. Let's just draw a little picture. If I have a right angle, I'm going to call it pi over 2. And I put in theta, then looking at theta and looking at the complement of the angle. So how do you do a complement? (90 degrees minus theta, but we're doing real He-Man angles now. Pi over 2 minus theta. And it switches opposite and adjacent. Okay, so the complementary statements are sine of the complement. Again, instead of 90 minus theta, we're going to be mature and use pi over 2. So sine just switches opposite and adjacent. So instead of opposite over hypotenuse, we have adjacent over, we have cosine. Fortunately, they come in nice matched pairs. Cosine of the complement is sine. Incidentally, that's why it's called cosine. It's a sine complement. Co stands for complement. Okay, tangent and cotangent go together. Because again, tangent's opposite over adjacent. You switch them, you get adjacent over opposite. And of the complement is cotangent and cotangent of the complement is back to tangent. And guess what happens with secant and cosecant? Yes. They switch also. So cosecant of the complement, 90 minus theta, is secant of the original, and vice versa. Okay. Simplifying. Okay, so we are going to be doing a bunch with trig identities and trig simplifications after the quiz. We're just starting a little bit now. When in doubt, try turning everything into sines and cosines and see what cancels. Okay, so sine times cosecant's 1 over sine. Cotangent is cosine over sine. Now there's two ways to simplify this. I can turn the top into 1, or I can cancel the over signs. Canceling the over signs, you may not notice it, but it gets you directly to the final answer, which is tangent. Let's do this the slow way, though. See that you get the same thing. The reciprocal of a fraction flips the fraction. And that's about as simple as it gets. All right, looking at this, I see a square. Namely, of course, cosecant squared, and a subtraction sign. So I'm thinking a trig identity.
Like 2A, look up previous problem.
So we'll factor out tangent first. And we say, okay, 1 plus cotangent squared. Let me fix that. If we move the 1 to the other side, we have cosecant squared is cotangent squared minus 1 is cotangent squared. So we'll replace it. At least we don't have a subtraction then. So notice, let me turn everything into sines and cosines for a minute. Cotangent is upside down and squared, so notice one of the cosines and one of the sines cancels, and you're left with a single copy of cotangent. Without the squaring, you just cancel down to 1.